In this lesson, we'll talk about a concept called average rate of change. This is a useful idea for all kinds of functions. We have in the past spoken about linear functions, and you know that linear functions, when graphed, they form a straight line, so they have a constant rate of change. And it's the m in y equals mx plus b. It is rise over run between any 2 points on the graph. But for this video, we're actually going to be talking about rate of change of any function. So we're going to start by looking at the formula that's given up at the top. Change in y over change in x. And we're given a table of values to start with. We have x's and we have y's. And we're asked to find the average rate of change of this particular function over the interval 0 to 2. So what I like to do, because there's a lot of information on this table, I like to just put 0 in for the first x and 2 for the second x, and then copy down my y values. X value of 0 has a y value of -1. X value of 2 corresponds to -5 on the y. And now I want to think, what is my change in y? How do you get from -1 to -5? Well, I'm going down by 4. Change in x, how do you get from 0 to 2? I'm going up by 2. So my change in y over my change in x is going to be -2. So that's my average rate of change over this interval, x equals 0 to x equals 2. Now we'll look at the little graph that's given here. And I have my x value for my interval, -1 to 4. I want to find my y value at x equals -1. So we go over to the graph. Here's x equals -1. My y value is down here at -5. How about at x equals 4? My y value is 2. And so now we're going to consider, what is the change in y? How do I get from -5 to 2? I go up by 7. How do you get from -1 to 4? I go up by 5. So my change in y over my change in x is 7/5. That's a positive number. So just to be sure, does it look like as I travel from -1 up to 4 along the x-axis that this graph is going in a positive direction? Yes, it does. Always want to look to make sure your answer makes sense. I want to take a look at this quadratic function right here. And I know that the rate of change of quadratic functions is not constant, but we want the average rate of change from x equals 0 to x equals 2. And we'll plug 0 in place of x right here and get the y value. 0 squared is 0. 0 minus 3 is -3. Now we'll plug 2 in for the x. That's 2 squared, which is 4. 4 minus 3 is 1. We can interpret our change in y here. To get from -3 to 1, I'm adding 4. To get from 0 to 2, add 2. So my change in y over my change in x is +2. And we can do that for any equation. We can find the rate of change between any two given values in an interval. So here I'm given 0 to 3. I'm going to plug in my 0 to find my y. 0 squared minus 0 plus 1 is 1. I'm going to plug in x equals 3. 3 squared is 9. 9 minus 6 is 3. 3 plus 1 is 4. And now I'm going to determine my change in y and my change in x. And I'm just going to write that down and simplify it if possible. So for this quadratic function, if I were to graph it and look at the interval 0 to 3, the average rate of change of that interval would be 1. So that's how we interpret average rate of change of functions.